Okay, give me a second. All right, so in our last lecture, I will send all these notes. I think these notes I have sent already. So we have stopped where the regular falsy method. Okay, so I'm in the middle of the, example. So I will complete it today, hopefully. Okay, so regular falsy method or false position method. Also, it has been named similar to secant method. Okay, you can check in the books also. It is, wait, give me a second. In the books, you can search the same method for secant method also. Okay, secant method also talking the same kind of approximately. Okay, so let's see what this method is saying. Regular falsy method is also breaking the interval into sub-intervals. So which has been, we have seen in the bisection method. It's going the same way, but choosing the next point is the different. In our bisection method, we have choose our next point as middle point. Like if it is a comma b, our next point will be a plus, b minus a, is that a plus b divided by 2, isn't it? Something like that. So the middle point, okay? But here we're going to see a small difference between the bisection method, but it is doing the same progress, okay? We can see that there is some rules. So you can see we first find an interval. First of all, we find the x0 and x0 and x1 in which the real root lies by checking fx0 and fx1. So our function, if you put the functional value for these values, so fx0 and fx1, then you have to have a opposite sign. Likewise, what we have done for all the methods. Okay. Then determine the approximate x2, which is our next point. There is some rules to find it. So let me, give me a second. Okay. So to find the next point, we have some rules. Okay, likewise the earlier method, we have some rules to find this one also. Okay, yeah. So it says to find this x2, we find the point of intersection of the chord. Okay, so what I have told you, this is our functions. So this is our x0. Let's say this is our x0. This is our point we have found x1. See, this is the positive one. This is the negative one as the functional value of fx0. So functional value of fx1. This is in the negative form. This is in the positive form. Okay. So if you find like that, so we have to know. Yes, we have found the interval of that. So our first interval would be x0 and x1. So it should be like a consecutive number, hopefully. Okay. Then what you have to do is we have to find the chord joining these points. Okay. And this is where our root is. Okay. This is where our root. So you have to do some approximation here to here. We have to reach it by some iterations. Okay. So it may take 2 iteration, 5 iteration, maybe sometime it may goes to 15 iteration because of the point what we have chosen. Okay, so because of the function also it depends our iteration. Okay, we don't worry about the iteration, only you have to consider where it approaching our root. Okay, so sometime for the time problem in the examination they may ask a simple question which don't take much iterations, or if it is, even though it is taking too much time, they may take ask you like less number of iterations, like 4 iterations, 5 iterations, something like that. Okay, so don't worry about that one. Only thing is you have to know which method they are asking for. So you have to know all. We are only studying 4 methods now, so you have to very clear about all 4 methods. Okay, so the chord joining the point, this is our x0 fx0, and this is our x1 fx1. So this is our chord we have found. That's what I have explained in the last class. Like to find the straight lines, we have to take 2 points, isn't it? So from that we have found this is our y. Okay, this is our Chode's equation. Then after we find our Chode equation, we can find our next point by see here, as I said, our Chode we can the root will be where this point, no, this is our Chode equation. Let's say that is our y. Okay, we have found the equation by this. But if you want to find the point y of x, let's say, okay, so wherever you put that x next x, let's say x or say xk, we don't know which point. If you put that one, you have to have that point should be 0, isn't it? In here we have only x value, no y value. Here no positive or negative. This in this point, in the x line, we know that thing, no, in the x-axis y will be 0, isn't it? So like that. So that's what we're gonna put. So for that, we have to put y is equal to 0 in this equation and x equal to x2. So this is a common general equation, no? So for to get the next point as x2, so you have to substitute for x, x2 and y is equal to 0. Then if you rearrange this equation, you will end up here. Okay, did you check that? So it should be a bracket, okay? Put a bracket here. So I hope you have derived the equation from and putting y is equal to 0 and x equal to x2, you may end up here, okay? So in some books I have found, books and some people, they even simplify this one and I think they are giving, can you, can you simplify this further? So for example, if I take my denominator, let's say fx1 minus fx naught. So if you cross product this one, what do you have? X naught of fx1 minus fx naught minus fx naught of x1 minus x naught. Can you simplify further? So you can cut out something, see? So x naught fx1 here, x naught fx. So you can do something, let's see. X naught, can you cancel out the bracket? This will be x naught fx naught minus x1 fx naught and minus into minus plus. Okay, be careful about the signs. Fx naught and divided by fx1 minus fx naught. So what are the common one? Here minus x naught fx naught and plus x naught fx naught. So it can be also simplified in this way. And some people use this one. Maybe that one also easy to memorize, I guess. Okay. Divided by fx1 minus fx naught. So when you are doing the example, you use this one, also this one. See whether you'll get the same answer. So you choose which one is okay. Okay. See, this can be easily memorized. Is that correct, my equation? Can you tell me? Let's talk together too. Is that my derivation is correct or wrong?
Okay, ma'am.
This one? Everyone should write with me, so then only you can find out. If I am making mistake also, let me know. Okay, one person answer. Where's the others? Let me check people are here active. Start. 024. Can you answer me? Is this correct? Registration number 024.
Yes, ma'am.
Yes, can you chat with me? You don't need to talk. You can chat with me. Can you answer me in the chat whether my the derivation is correct or not? Yes. That's a 24. Okay, thank you. Okay, so good. So see here, I will show you why I have chosen that one also. Rather than see x naught minus fx naught, fx1, fx naught. So many things are there now. Rather than that, see how nicely I can remember this one. X1, sorry, x naught, correct me if I'm wrong, x1, fx naught divided by fx1, fx naught. Is that correct? The way I written? So it says, see how nicely we can remember this one. First of all, see fx1 minus fx0. Same here, fx1, fx0. Only thing is you have to multiply the different way. See, you keep them, keep reminder fx1 minus fx0. That is the upper part and lower part. Okay. If it is fx1, you have to multiply by fx0. If it is fx0, you have to multiply by x1. So it is, I feel it is easier to remember than this. Okay. So anyway, we have found both are equal. So you can choose both way. Okay. Or either if you can't do this one, you can use this one, or use this one. Okay. And also you use, when you are doing the exercise, you use both method. See whether you get same answer. Okay. Right. Next one. The next point is, if after, see here, this is our x0, this is our x1. Okay. So we have found one x2. Let's say this is x2. This is our positive, this is our negative, let's say. Okay. Then only if you multiply these two, I mean not the x0, fx0. Okay. fx0 and fx1 are both are opposite directions. So to find out whether this interval or this interval we're gonna take, we have to go for the step number 3, which says next compute the fx2. After you find out the fx2, you find out the fx2. So and determine the interval in which the root lies. If fx2 and fx1 are opposite sign, let's say this is plus. So both are our this is after this one we have our bisection method. Okay, bisection method continues. What it says, if it is plus, we can't take this, not this interval, take this interval. That's what they say. So if it is opposite sign, the root lies x2 and x1. Otherwise you have if it is minus, so you don't take this side, you reduce this side. Okay, that's what it says. And then they say the next approximate root x3. Okay, after that we have to find the x3 now. X3 determined by changing the x0 by x2. So that what they say is, this is my x0, this is my x2, this is my x1. So we have found out our equation. It's between, let's say this is my interval. I have found it. Then he said to take the x3 by changing this x0 has changed to here now. So we don't take this x0. Now our x0 is changed into here. That sorry, yeah, x0 by x2. This is x0 and x2 are same place. Then you find the x3. Why they are saying is, when you're gonna use the same equation, this equation. So on that sense, in this x0, you choose as x2. Okay, the point of x2. Otherwise, you choose the x1. So otherwise, if it is our interval has changed into x0 and x2, you change our x3. To get the x3, you have to change this one as this is equal to x1. Don't take the early x1, cut out and take the new interval and transform this x2 as x1. Okay, so that's what they say. Anyway, when we are doing example, it will be very easy. Okay, so we have to continue until when? Likewise, in our other method, you have to continue until the root computed to the desired accuracy. For example, they may say to find within the error of 0.0001. So you have to take x3 minus x2 is equal to, should obey this. Or otherwise, if you find something x2 also, let's say my x2 is 1257, my x3 also somewhat 12569, like that. This is also same, no? Yeah. So in that case, you can stop. Okay, maybe in the third iteration or 5 iteration according to your questions. Okay. So this is the regular falsy method. So hope you understood. Okay. So let me start and do the example, then it will be okay. Okay. So I can go to the next chapter. Okay, let me take the whiteboard first of all. Okay. Okay, do with me and you have to answer. Okay, I'm not gonna do full things. So you can answer me. Hope you have done already, so you can give the answers. Okay. So our question, example question is x cube minus 3x minus 5, which is equal to 0. This is our f of x. So to solve using the, what is the question? Using the regular falsy method to the correct, to the four significant figures, isn't it? 4 significant figures. Is that our questions? Yes. So we know what is 4 significant figures, isn't it? So first of all, we have to choose our interval. They didn't give us, so we have to do it. Okay, x and then fx. So better we choose some consecutive numbers. If it is 0, what is the answer? 0, 0, minus 5, no? Okay. If it is 1, 1 minus 3 minus 5, so minus 7. If I'm doing wrong, please tell me. Okay, hope you have done already. This will be 3. Let's say 2. So these are minus minus, so not possible. Let's say 2, it will be 8 minus 6 minus 5, which is equal to minus 3, no? Yeah. Okay, this is also not possible. Okay, so I need to go further. So if it is 3, so 27 minus 3 into 3, 9 minus 5, which is equal to 14. So 3, 1, 3, no? Am I correct? So we got plus. So we can stop our searching and we can take our, therefore, the root lies in the interval. It is 2, 3. Okay. Up to now, okay? Let's see that. Minus 7 minus 3, 13. Okay, good. Okay, so this is our, so after you finding this done, write down like this. Therefore, root lies in the interval 2, 3. You have to put it in the close bracket. Okay. So I'll erase the board. Okay. So we have found our x0 as 2, x1 as 3. Okay, according to our steps. Okay. So to get the x2, so let's try our, I hope you have tried the older version of the formula. So I will try the next one. Okay. So it will be x0 fx1. See, I can remember quickly. So it will be x0 divided by fx1, this one minus this, isn't it? Okay, tell me what is this? x0. x0 will be 2. 2 times of, what is the answer? fx0 will be minus 3 and 13, no? Yeah, fx1 is 13. So times of 13 minus 3 times of minus 3. So if it is negative, put it in the bracket. It will reduce your, any errors. Okay. So minus 3. Can you find the answer for this one? Is that 2.1875? Hope you have done already. So give me the answers. Let me see. Yes, good. I want everyone to answer me, okay? Okay, give me a second. Okay, that's fine. So after we finding our new point, okay, x2. So x2, we know surely in between 2 and 3, 2.1875 somewhere here. Okay, first of all, you have to find out fx2. After that, you have to find fx2 is equal to, therefore, fx2 is equal to what is that? F of 2.1875. So what is our f? F is a function of x cube minus 3x minus 5, which is equal to 0. Did you learn the way how to, put the function in the calculators? 2.188. How you got that one? 2.188? So you may, I don't know, you just try again with your calculator. So it seems like round off. Okay. No, not at all. You have to get your significant figure at last, not from the beginning. Okay. So you have to get your answer at the last point. After we find all the iteration and we come to something like, let's say, my answer is 1, 2, 5, 7, 3, 8, 2, 1, something like that. Okay, this is my final answer. Then at the last point only, you have to take the 4 significant point. Don't take at the beginning. Okay, it will make wrong. You better take like, 4 decimal point or 5 decimal point like that. Okay, without getting any errors. Okay, hope you understand. So give me the answer for this one. Okay, good. So the answer will be negative 1.095. Okay, down. So what do you think? This one our negative, this one also negative, this one will be positive. So where will be our, sorry, this one is negative. So where will be our new interval? So this is not possible now. So I need to cut that out. So I need to take this x naught to here. Okay. So I can take this one as my new x naught. So this is my new interval. Okay. Therefore, the new interval. So you have to tell, okay, before that, okay, I'll erase this part. Have you got written? Because this is the last week question, so I'm doing quickly. Hope you have your answers. Okay. So what is that? This is our x naught, this is our x1, this is negative, this is positive, this is x2, this is also negative. So we have to have, this is not our, therefore, first of all, you have to tell my fx2 is negative 1.095. Therefore, fx naught and fx2 gives positive value. And, but fx2 times fx1 only giving negative value. Therefore, the new interval will be x2 comma x1, which is equal to 2.1875 comma 3. It's our new interval. This is how you have to write very clearly. Okay, in the exam or even in your notes also you write very clearly. Then only you can understand. All right. So still we are not finished. So we have to go to the next iterations. So let's try our next iterations. So we have found our x2 and x0 are same now, 2.1875. And this is our x1, which is equal to 3. Okay. This is negative. This is positive value of functional value. Therefore, what is our x3? Here in our, again, x0, you keep, use that the same equation. So you can transform x0, x2 to x0. So it will be very easy. Okay. So fx1 minus fx0. So what is the new values? So our x0 will be this one. So 2.1875 times, what is our fx1? So this is 3 now. This will be 13. Sorry. This is, give me a second. This is, what is the functional values? Functional values 13. And then this one is negative 1.095, isn't it? So we have to use that one. So this will be 13 minus x1. x1 is 3 times negative. So wherever you find the negative signs, you better use the brackets. So it will help you to reduce your errors. Okay. So this minus this, no? 13 minus 1.095. So give me this answer. X3 is. So our meeting will be end in 10 minutes. Okay. If it is so, please join again. Okay. Okay. Let me see the answers. Okay. Answer is 2.2461. Is that correct? I don't know. It's someone's answer. Okay. They have used here 49. Okay. And this calculation, they have used this one. 7, 5, 10, 13, 3 minus. Is that correct? Please check. 2506. Why everyone having too much of different? Okay, check again. Okay, maybe I'm using other method now. Maybe I don't know whether you better use the full format. Okay, so 2.25062. Some people got like that. Maybe it's the correct answer. They don't know. They have put 4. Okay, you check again using your calculator. Check again also. So maybe my other answer also may differ from yours. So I hope you got the idea. So it doesn't matter. But you check yourself. Everyone get the same answer. Okay. So you better, because of the 4 decimal significant figure they have asked, when you are giving the answer, when you use the things, you use the calculator original value. Okay. When you are giving here, you give the some number of some number of values here. Okay. So I think they have gone x4, x5, x6. Okay, same way. I think until they have gone to x8. Okay. So did you find where you have found your correct answer? So they say their correct answer is therefore the root after going to 8 iteration, they say therefore the root in 4 significant figures is they are approximately they are saying 2.279. Is that correct? At least I don't know. What is your final answer? They have found the root at the x8. Okay. And they have approximately, they say, see, 1, 2, 3, 4 significant figures. So if you give like this, for example, 2, 7, 9, 5, 2 like that, so you won't get the last marks, 5 marks or something. Okay. So you have to cut out with the 4 decimal places, 1, 2, 3, 4. Okay. So there you have to take over that our significant figures notes. Okay. Go and check how to find it. 2.25. Okay, I don't know. What is the final answer? Give me. Have anyone found up to x8? Why? Because they are saying x8 is, okay, I don't know. You may also find like that. So what they have found is, they have found what is x4, what is fx4, x5, fx5. Like that, they have found all these things. Up to x7, they have something like 2.788. Then f of x7 is 0.0 is equal to 0.028, 0028. Okay. Then x8, they have found like 2.2792 something. And f of x8, they have found 0.0022. So both are coming plus plus. So they have stopped. Okay. So because it has small different, only small differences after the fourth decimal place. Okay, sorry. Yeah, fourth significant figure. So they have stopped there and found their root as 2.279. So I don't know, you have gone up to x8 or something. So do it again, okay? Using both method, both formula, okay? Earlier formula and our simplified formula, and see whether how you reaching your answers, okay? So that's all about the regular falsy method. So I will stop here for the chapter 1, okay? So let me go back to the notes. So I have created your homework quiz. I will send you today, okay? You can try. I also have put one questions. It says, okay, give me a second. Okay, one question it says, at last, after finding fixed point iteration, again, regular falsy method, there's another question it says, compare the results like in a tabular form. For example, you after that, for example, one question, let's take x cube minus x minus 1. The same question come all 4 methods now. So you may have the answers. So you just compare what is bisection method like this. This is x1 value. What is this? X0 value. What is this? X2 is what? Up to you go somewhere, no? Like, for example, we have gone up to x8 for regular false method. So there are 4 methods. Bisection method, Newton-Raphson method, and fixed point method as regular false method. So you put whatever x0 you have found, like x1, x2, up to x8. Some point you may stop here, x5. Some point you have to go further. Okay, so here you can compare the results. You can see which method is best one, which method is going, to the roots very faster. So you can analyze that. Okay, so that's what the last question is. So I have put the same question for in all 4 methods. So you try in all method and then create one table to compare our results. Okay, so that's all about the question number. I think question number 3 says, okay. So that's all about our chapter 1, okay. Chapter 1 has finished. Okay, what we have seen so far is in our chapter 1. So we have seen number system, what is error, solution equation of nonlinear one variable equations with using bisection method, fixed point iteration, method of false position, the regular false position, as well as Newton-Raphson method. So we have finished our chapter 1. So we will have our continuous assessment 1 on this. Okay. And of course, in our semester, our first question will come in this area. Okay. So I hope to cover all the sections, so you better understand everything and get ready for that. Okay. Okay, let's move to the chapter number 2. So I think, okay, within 1 minute our meeting will finish. Please join again. Okay. So first of all, I will start again anyway. I will send both notes, rough notes for you too, but better you write down. Okay. This is our chapter 2 is about some polynomials methods. There are some collocation, factorial, oscillating, Taylor polynomials, as well as some difference equation. We can see that one in the next class. So let's start our polynomials. Okay. So this also I have divided into two sections. One is for polynomial, other one is for difference. Okay. So what do you think? The polynomial. Can you give one example polynomial? You have heard, no? As a meaning of polynomial. Okay, let me see the answer. What is that?